Hello, this is the second video in a series of 6, which is all about the circle properties. This video will explain the property where angles that are in the same segment are equal. Okay, and as with the other videos, I said I'm going to give you abbreviations and ways in which you can actually memorize these laws. So for this one, I have chosen SS. Okay, the first one, remember, was C to C. Okay, now the second one is SS, and that comes from same segment. So it's about angles in the same segment. Okay, let me explain what this law says. Right, you have a circle, right? And you must have segments of the circle. Now, a segment of a circle is formed when any 2 points on the circumference, okay, are joined or not joined, but you have 2 points on the circumference, and this line, people, divides your circle into 2 segments. This case, the upper part and the lower part. So this is one segment, and we in fact call it the major segment simply because it is the largest part. And this one would be called the minor segment. Okay, because it is the smaller part. But the point I'm making, if you have 2 points on the circumference, okay, when you join them in a straight line, you will then divide it into 2 parts. And each of these parts is called a segment. Right. Now, this law is about angles in the same segment. So what does that mean? You must have point 1, 2 points on the circumference. Okay. And this line between the 2 points on the circumference is what we call a chord. Okay? A chord joins 2 points on the circumference, and that then divides your circle into 2 parts, and each part is called a segment. All right. Now, the law of angles in the same segment means you must have another 2 points anywhere on the circumference of the major segment or on the circumference of the minor segment. Okay, so you have another 2 points, and these 2 points are both joined by the 2 ends of your chord. Okay, so I take my one end of the chord and I draw a line to my circumference point, and I take my other end of the chord and I draw a line to the point of the circumference. Okay, so this now becomes an angle in the major segment. At the same time, from the same 2 points, so those that form the chord, okay, you have a line to another point on the circumference, and from the other end of the chord again to the same point on the circumference. Okay, now this angle and this angle lie in the same segment. Can you see that? And the law says they are equal, which means that this angle, if that is x, then that one is also x. So angles in the same segment are equal, right? Remember, a segment is formed when you have 2 points on the circumference, okay? And I prefer always, people, to draw in the chord, because it just simply makes it clear what is your segments. So when you draw the chord, people, you clearly see that this is the one part of the circle and this is the other part of the circle. So you have two segments, right? And then how are these angles formed? Important. From the two ends of your chord to one point on the circumference, okay, those two lines, and again from the same two ends of the chord, the same chord, to the other, to another point on the circumference. Then these two are in the same segment and they are equal. I want to just quickly show you, if you have that, right? Let's just turn around the page. Then you will clearly see that between these 2 points, I also have a chord, isn't it? Okay. And now this whole part of the circle becomes a segment. Okay. This whole part becomes a segment. And again, you now have two lines from one end of the chord. Okay. So that forms a angle in the segment. And in the same segment, you have another two lines, meaning coming from the ends of the chord onto the circumference. Okay, so that is in the same segment. So if this was angle Y, then that one was angle Y. So remember, people, that if you have angles in the same segment, okay, you always have a pair of equal angles. Okay, so in this case, these two, and as I said before in the videos, turn it around, ensure that your chord lies horizontally in front of you, and it is much easier to recognize the angles in the same segment. So that is the law, where the angles in the same segment are equal. Right, let's look at an example. The following drawing is given, and they just simply state that you must find x. Okay, so this angle is x. Right, I'm going to turn my page around, because when I do this, I can now see that I've got 2 points on the circumference, and when I join them in a straight line, which means if I draw a chord, I now divide my circle into the major segment and the minor segment. So let me just color this. This is one segment. And people, maybe you will all, now very easily recognize that you've got two segments, two angles in the same segment, which is this one, which you need to find, which is angle X, but also that one is angle X. Why? Because, let me show you again, from the one end of the chord to a point of the circumference, you've got a line, okay? And from the other end of the chord to the same point on the circumference, you've got a line. So this is an angle in that segment. But at the same time, you need a second angle. So from this end of the chord, you've got a line into the major segment, and from the other end of the chord, you've got a line into the same segment. So these two are equal. Okay, now I taught you just now, just to show you, let's turn it around. Okay, then if you make this the chord, then that part becomes a segment, and maybe you recognize that now this angle and that angle are in the same segment. So we already know that this angle is also 68. Okay, so they are asking you to find angle X, right? If you look at this triangle, okay, we have the angle of 100, we have the angle of 68, and we have the angle of X. So if we have 100 plus 68 plus X, we get the interior angle sum of a triangle, which you should know is equal to 180 degrees. Okay, and you can just simply calculate that. Okay, so we have 180 minus 100 is 80, minus 86 is 12. So X equals 12 degrees. Right? There are other possible ways in which to calculate that, but do you see that in this case, turning your page around and recognizing these two angles being in the same segment, okay, actually makes this solution very, very easy. So don't forget, as soon as you have a chord and you have angles in the same segment, okay, you always immediately have two pair of equal angles. Okay. How do we remember this one? Angles in the same segment is double S. Angles in the same segment is double S.